right, welcome back, students. This is the last section for Unit 5 notes. It's a little out of order, so it does go 7.5 and then go back to 7.4. Here is the answers to the warm-up. Make sure you complete this. But at this time, if you obviously want to look over your work, just pause the video. I am going to move on to the lesson. So 7.4 has to do with similarity in right triangles, and we're going to be looking at this idea of geometric mean. I think it's really cool. It has to do with a triangle, well, two triangles within a triangle. So if we were to take a particular triangle and we were to look at it, and we were to, for instance, take this and copy it and paste it over here. I'm going to make one that's a little bit larger. If we were able to flip this around, this original triangle, and slide it into here, let's see. Imagine I could flip that so that it looked kind of like this. This is a geometric mean problem. A geometric mean being that this shorter side here, that this shorter side here to this longer side here is proportional to this triangle's shorter side here to its longer side here, as it is to the outside triangle's shortest side here to its largest side here. So really, in this triangle, I call it the small, medium, large, or short, medium, long. But every one of these has, for instance, 3 sides. So take a look at this triangle again. This is the smallest triangle within this set of triangles. Its longest side, the smallest triangle, its longest side is the hypotenuse. Notice that it is also the shortest side of the full outer triangle. Okay? And then let's take a look at this other triangle, this smaller one, the medium triangle here, this one. Its hypotenuse is the length of the longer side of the outer triangle. And then the triangle itself, its longest side is the longest side. What I'm trying to say here is that the 3 triangles, small, medium, large, makes up this outer triangle and all of its sides. So that is what we call geometric mean. Let's start looking at the notes here. So the altitude of the hypotenuse, again, the altitude is that thing that comes directly downward towards the base of the triangle. I drew it right here. Here I'm going to drag this triangle over. That is an altitude. See that right angle there? So the height of the triangle, let me rearrange it. I'm going to spin it. Whoops. So it's easier to see. Let's try this again. That right there, the height of the triangle is its altitude. I'm off a little bit here. I'm going to try to redo this. That's your altitude. So the altitude to the hypotenuse, again, the hypotenuse being opposite that. So I'm going to put in a right angle here. So you have your outer triangle, which looks like it's upside down. The hypotenuse, it's lying on its hypotenuse. That right there, that other altitude coming down, broken into 3 congruent triangles. So the altitude to the hypotenuse of the right triangle divides the triangle into 2 triangles that are smaller to the original triangle and to each other. Are similar to the original triangle and each other. So there's 3 triangles again. So the proportions in which the means are equal occur frequently for any positive numbers a and b. The geometric mean is of a and b is a positive number such that this happens. So let's take a look. So Let's call this A. And let's call, let's call this small side A. So here's a small side of the smallest triangle. And then let's call this altitude X. Well, that's the longer side. Now turn your head and focus now on the larger triangle that's right here, right? Think about its smallest side. That is X. And its larger side I'm going to call B. So what I'm saying is, if we were to take this triangle here, this smaller one, I'm going to pull it, I'm going to try to pull this out. We have A is to X, and then that's the same as, whoops, as X is to B. That's your geometric mean right there. So what we're going to say is that A is to X as X is to B. These are proportional because they're similar. So if we find the cross products, we get X squared equals AB. So the square root of both sides, we have X equals the square root of AB. That is what this is stating, that the geometric mean X will always be equivalent to the square root of A times B. It just works out that way because they're similar. So the length of an altitude or a hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. And the altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg in the triangle is the geometric mean of the length of the adjacent hypotenuse segment and the length of the hypotenuse. Let's get into actual problems so you see the actual numbers. I think that's going to be easiest. So in number 1, it just says find the geometric mean of 4 and 18. So when we go to find the geometric mean, we're going to say X equals the square root of 4 times 18. All right, so X equals the square root of 72. So X approximately equals the square root of 72 is approximately 8.485. So we're going to say about 8.5. So let me explain what that means. That means that the geometric mean, so I'm going to put numbers with this. So this is 4. That part's 4. This part's 18. That means that this part right here is about 8.5. That's all that we did. So I'm going to redo this over here. I'm going to do another example with a geometric mean of 15 and 20. So I'm going to erase the, so now this is not really drawn to scale. I'm going to have to redraw this triangle where it looks more accurate, where it's 15 and 20. So I'm going to do here, do something a little bit larger. I'm hoping that's a right angle because it really should be. And then here's an altitude. And I'm going to put 15. This still isn't drawn to scale, but go with it. We have 15 over here. We have, let's do 15 and 20. So I'm looking for this height here. So I'm going to say that X is 15 times 20. So X is the square root of 300. and the square root of 300 is about 17.32. So I'll say 17.3. So this is about 17.3, that altitude. All right. So let's now utilize the geometric mean here. So here's what's really cool. We have our smaller triangle, this one. We have a little bit larger one, this one. And we have the whole outer one, which is the largest. So if you're wondering what the smallest side is on the outer one, the one in blue, it goes small, medium, large. The sides go in order based on the hypotenuse of the other triangles. So the smallest triangle, its hypotenuse is the shortest side of the outer one. The medium triangle, its hypotenuse is the middle length side, and then the hypotenuse is just the hypotenuse of the outer triangle. So we're going to say 4 is to y as y is to 5. That's it. I'm going to rewrite it a little bit neater. 4 is to y as y is to 5. We're going to get y squared. Y times y is y squared. Y squared equals 20. So the square root of y squared equals the square root of 20. So y is equal to the square root of 20, which is about 4.47. So here we have 4 is to 4.47, as 4.47 is to 5. 4.47. So again, the left-hand side is our smaller triangle because it's 4 and 4.47. And then we have your medium triangle, which is the 4.47 to 5. The question is, how can I utilize x here? Well, that's the hypotenuse of the smallest triangle. Therefore, it's actually the shortest side of my biggest triangle. So I'm going to say 4 is to y. I can't do that. Let me look at let's see. The only numbers I can use is the shortest side of the outer triangle and its hypotenuse. So I can only do x is to 9. So now I need to pick either one of my triangles, and I'm going to pick the smallest one, and I'm going to say 4, because that's the shortest side, is to its hypotenuse, which is x. So I'm doing 4 is to x, so the shortest side of the smallest triangle and the longest side of the smallest triangle, its hypotenuse. And I'm doing the same sides in my outer triangle. So I'm going to get x squared equals 36. So x, the square root of x squared equals the square root of 36. So x equals 6. So we have a value of 6 that x would have to be. It's a little bit tough, but you gotta talk, just like I did, you gotta talk your way through it. Think about, you have 3 triangles and you have a small, medium, and large side for each triangle. So you're just comparing the ones. Like what I did in blue was the shortest and the medium side. I compared those of the smallest triangle, and then I took the shortest and medium side of the middle triangle and compared them. So I'm going to do the same thing over here for this one. I don't know why this is so far off to the side here, but yeah, let's work with it. So I'm going to say 4 is to y as y is to 12. So 4 is to y. So it's the shortest in the middle of the smallest triangle, and the shortest in the middle of the larger triangle, of the middle, I'm sorry, the middle size one. So y squared equals 48. So square root of y squared equals square root of 48. So y approximately equals square root of 48 is about 6.928. So I'm going to say 6.6 I'll round to 2 decimal places, so 6.93. And all right, I'm going to erase that. Now I need to solve for x. So it looks like I'm going to be doing the smallest triangle, small side, and its hypotenuse. And then I'm going to do the outer triangle smallest side, which is x, and its hypotenuse, which is going to be a total of 16. So I have x times x is x squared, 16 times 4 is 64, square root of x squared equals square root of 64, so x equals 8. Oops. Hopefully by now you're feeling a little bit better about how to set these up. If you are still struggling and you're like, what in the world is happening here? Write out your triangles separately. So you might want to, for instance, draw out this triangle here. Let's do it in a different color. You might want to draw out this triangle and say, well, that's x and that's 4 with a right angle right there. Then you might want to write out this triangle. If you spin and you get to look at it in a different way, you have 12 as the long side and y as the height. And then you have this one going in the other direction, but that's your outer one, and that you have x, and you have unknown, but you have a length of 16. And those are the pieces that I matched together. So I did 4 and oh, I'm sorry, I messed up myself. 4 with a hypotenuse of x, and then you have y with your 12. That's why. This one, the smallest one has 3 values. It has x, it has y, and it has 4. There we go. And then these other two are y and 12, and then, yep. And then from there you match up the pieces that you want to, that match up here. So like 4, y, and 12, those match up. You have 4 and x and 16 in the other two that match up. So that's a great strategy, is like breaking them apart and writing them out, if that's what's going to help you. All right. Hello, students. Sorry about that. I'm having a little bit of a recording issue, but I think I fixed it. So in the last example, example 3, we have a real-world connection problem. We have Maria here, who is walking from a parking lot over to a lake. And from the parking lot over to the information center, which I labeled, has a distance of 300 meters. The location from the parking lot to the canoe rental has a distance of 400 meters. We're also given that when she walks from the parking lot to the lake, she sees a sign, and that sign mentions that she is 320 meters away from the dock. So that information is relevant. I'm going to label that side DB, 320 meters. So I'm going to draw out the 3 triangles that we have just so we can see them. We have our smallest triangle, which has a side that is x and a hypotenuse of 300. We have a bigger triangle, still going in the same direction. It's a right angle. It has a side length of 320 at its base. It also has a hypotenuse of 400. And that's all that we know about that one. We do not know its height. That's from D to C. And then we have the outer triangle here that has, it's going the other way. It has a base of 400. It has a height of 300. It also has a hypotenuse, and that hypotenuse is unknown, but it's x plus 320 meters. It's both x and 320. And that's triangle ACB, the outer one. So what I'm going to do is I'm going to set up an equation here and solve for the missing side AD. So I'm going to say that x is to 300 as, and I'm going to pick 300 is to this total x plus 320. Now that's going to leave me, that's going to leave me with a squared value, and I'd rather not, let me think, I would rather not have x squared. So let me choose a different setup. I'm going to choose, instead of those, I'm going to choose 320 and 400. I'm going to choose 400 and x plus 320. That way, I'm left with just an x and no x squareds. Either way, it will get me the x that I'm looking for. It is going to involve some algebra, so 320 times x plus 320 is equal to 400 times 400, which is 160,000. So I'll get 320x after I distribute. Let's see, 320 squared is 102,400. I'm going to take away 102,400 from both sides. And that leaves me with, let me try that again, 160,000, take away 102,400. Leaves me with 57,600. And I am then going to divide both sides by 320. And I'm going to get x equals 180 meters. So the answer here is Marla is 120 meters from the information center. So Marla is 120 meters away from the info center. So how far did Marla walk from the parking lot to the lake? And that doesn't have a value. So what I'm going to do, I'm going to erase those. Now that I know that that's 180, I'm going to create a new variable here. I'm going to call it y. let's do purple. I'm going to call it Y. And I'm going to say X is to Y as Y is to 320. So I'm doing X is to Y as Y is to 320. So I'm doing short side is to long side as short side is to long side. The thing is, I do know what X is because X we found out to be 120. So I'm just going to substitute in my 120. I'm going to find the cross products, and we get Y squared. And we're going to do 320 times 120. So Y squared equals 38,400. The square root of Y squared equals the square root of 38,400. And when I find the square root of that, what did I do wrong? X is to Y as Y is to 320. Oh, it was 180. My apologies. 180. X is 180, not 120. So 180 times 320 is 56,600. So the square root of 57,600 is 240, exactly. 240 meters. So Marla walked, looks like Marla walked 240 meters from the parking lot to the lake. All right, looks like it recorded fine. So this will be it. This is the end of the lesson, and you guys can start your homework. And we are done with Unit 5, Triangle Similarity. Thanks.